For more than 20 years, the Colorado River's story seemed to be written in drought and decline, a slow-motion crisis unfolding before our eyes. Once a mighty artery of the American West, the river was reduced to a trickle in places, its future uncertain and its fate debated in boardrooms and kitchen tables alike. It was as if the river had become a giant bathtub, the taps barely dripping, while the drain gaped wide open, swallowing more than it gave. The millennium drought shrank this vital waterway, leaving behind ghostly white rings on canyon walls, silent witnesses to the water that once was. Scientists and water managers braced for a future defined by scarcity, poring over maps and data, searching for solutions as the river's lifeblood ebbed away. But then, in late 2023, the script flipped in a way few could have predicted. Snowpack in the Rockies piled up to levels not seen in years, and relentless rain swept across the basin, sending torrents of water rushing into the Colorado. This sudden reversal left scientists astonished, challenging everything they thought they knew about the river's rhythms and resilience. The unexpected surge wasn't just a welcome relief, it was a profound puzzle, raising new questions about the forces shaping the river's fate. It forced a critical question: what did we miss? How could so many experts, armed with decades of data, be caught off guard? The entire management of the Colorado River, from city planners to farmers, relies on forecasts to make decisions that affect millions. When those forecasts are wrong, it doesn't just undermine confidence, it threatens the very foundation of future planning and water security. The surprise wasn't just the river's rise, but the sheer scale and speed of its recovery, as if nature had decided to rewrite the rules overnight. It's a humbling reminder that, for all our science and planning, nature's forces remain unpredictable, always capable of surprising us, and always demanding our respect. To truly grasp the recent surge of concern over the Colorado River, we need to look deeper into the science behind its decline. The story of this river is not just about water levels dropping, it's about a complex web of human decisions, climate shifts, and ecological responses that have unfolded over decades. We must first understand why the river was shrinking in the first place. The signs were there: receding shorelines, exposed riverbeds, and reservoirs that once brimmed with water now sitting at historic lows. For nearly a century, states along the river's path were entitled to more water than the river could actually provide. This overuse was built into the system, as water was diverted for cities, farms, and industries, all relying on a promise the river couldn't keep. The root of this overallocation was flawed data. Early agreements were based on measurements taken during an unusually wet period, leading to unrealistic expectations about how much water the river could deliver year after year. But nature had other plans. Rising global temperatures have played a huge role, with warmer air acting like a sponge, pulling more moisture from the land and water. Warmer winters have changed the very nature of precipitation in the region. Instead of snow slowly melting and feeding the river through spring and summer, more rain falls, and snow that does accumulate melts much faster, causing water to rush away before it can be stored. Meanwhile, plants in the river's upper basin have become thirstier as the climate warms, drawing even more water from the soil and riverbanks, further reducing the flow downstream. At first, scientists suspected that sublimation, the process where snow turns directly into vapor, was to blame. But deeper research revealed the real culprit: the biosphere itself, with plants and trees absorbing more water than ever before. The combination of historical overallocation, rising temperatures, and thirstier plants created a perfect storm, accelerating the river's decline and leaving entire ecosystems and communities at risk. Water managers have long relied on forecasts based on snowpack depth, believing that a healthy snowpack would guarantee a strong river flow in the months ahead. But these forecasts kept coming up short, leaving communities in a state of uncertainty and forcing them to make tough decisions about water use and conservation. The snow was there, but it wasn't translating into the expected river flow. More and more, the water was vanishing before it could reach the people and places that depended on it. This vexing problem has forced painful cuts to water use, challenging communities to adapt and rethink their relationship with the river that has sustained them for generations. Every spring, water managers awaited the Colorado River's streamflow forecast. This prediction determined water use and power generation. But for 20 years, the river delivered less water than predicted. The models were too simple, assuming more snow equals more water. They failed to account for spring conditions, warmer, drier months. Lack of spring rain accelerated evaporation and plant uptake. A study revealed this accounted for nearly 70% of forecasting error. This overestimation led to optimism, followed by disappointment. Water managers faced shortfalls, forcing emergency measures. The failure wasn't in measuring snow, it was underestimating climate impact. The system was leaking, and we were looking in the wrong places. The winter of 2023 to 2024 arrived like a miracle. Atmospheric rivers slammed into the west, burying the Rockies in snow. Snowpack levels soared, a powerful dose of medicine for the parched landscape. The real surprise was the wet spring of 2024. Cooler temperatures and continued rainfall changed everything. The cool weather slowed snowmelt, reducing evaporation losses. Rain quenched plants, allowing snowmelt to reach the river. Reservoirs began to recover, streamflow forecasts exceeded expectations. The dramatic recovery provided tangible relief to millions. It was a powerful demonstration of atmospheric alignment. The deluge washed away old assumptions, flooding science with new questions. The 2024 rebound of the Colorado River challenged scientific consensus. The narrative had been one of inevitable aridification. The surge was an outlier, a black swan event forcing re-evaluation. It exposed the limitations of relying on recent history for forecasts. The future might be a roller coaster of droughts and intense recoveries. This weather whiplash presents a new management challenge. Scientists are exploring radical explanations for climate shifts. The event served as a humbling lesson in scientific humility. Complex systems like the Colorado River have immense capacity for surprise. Our models need to adapt to new planetary behaviors. The event forced a pivot towards models accounting for increased volatility. The remarkable surge in the Colorado River during 2024 led scientists to rethink what truly drives river flow. Traditionally, snowpack was seen as the main factor, but this event shifted the focus to the vital roles of soil and forests. Researchers began to ask, what happens to all that melting snow before it reaches the river? The answer, it turns out, is more complex than anyone expected. A pivotal study revealed that spring rainfall, not just winter snow, acts as the master variable controlling river flow. This discovery challenged decades of assumptions and opened new avenues for understanding water cycles in the West. Spring rain determines whether the snowpack transforms into a gushing, life-giving river or dwindles to a mere trickle. The difference can mean millions of gallons of water for communities, farms, and wildlife. In dry springs, when rainfall is scarce, thirsty plants and parched soils soak up much of the melting snow before it ever reaches the river. Forests and grasslands act like sponges, drawing in precious moisture to survive. Meanwhile, the relentless sun bakes the exposed soil, increasing evaporation and further reducing the amount of water that can flow downstream. This double loss, through both plants and evaporation, can dramatically shrink river flows. In contrast, wet springs bring generous rain that quenches the thirst of plants and saturates the soil. When the ground is already moist, it can't absorb much more, so melting snow runs off quickly and efficiently. As a result, meltwater flows rapidly into streams and rivers, with less loss to evaporation or plant uptake. This process helps maintain strong river flows even as temperatures rise. This new understanding has profound implications for water management across the region. Water managers must now consider not just how much snow falls in winter, but also how spring weather shapes the fate of that water. Future forecasting models will need to incorporate detailed spring weather predictions, including rainfall and temperature, to accurately estimate river flows and plan for drought or flood. Knowing what happens in spring is now just as important as tracking winter snow. Both seasons work together to determine the river's fate. This research gives planners and communities new tools for more accurate, adaptive water management. It helps them prepare for the uncertainties of a changing climate. Ultimately, understanding how plants and rain drive the river empowers us to manage water resources in harmony with the ecosystem, ensuring a resilient future for people and nature alike. The Colorado River's events left a mark on all who depend on it. The drought relief brought temporary security to communities, but the drought isn't over. The trend of aridification continues. The lesson is about resilience and adaptation. Old management methods are insufficient for a volatile climate. We need flexible approaches for weather whiplash. This experience spurred a revolution in forecasting science. New models provide more accurate, timely information. Better forecasting helps balance agriculture, cities, and the environment. The river's revival is a story of hope and resilience. It reminds us that nature is dynamic and solutions are possible. By embracing science and cooperation, we can secure our water future.